Today we're going to be talking about energy. And the three types of energy we want to talk about are ATP, NAD+, and FAD. ATP contains energy that can be used directly by the cell. NAD+ and FAD are carrier molecules. Think of them as empty trucks. And they are used to shuttle energy from one location in a cell to another location in a cell. Let's start by drawing ATP. ATP is simply a modified nucleotide. It consists of a sugar called ribose, and ribose is a pentagon. It's got an oxygen at the top, two hydroxyl groups, and a carbon. The carbons are numbered 1, 2, 3, 4, and 5. The base here is called adenine. And together, the sugar ribose and the base adenine are referred to as adenosine. In addition, we have three phosphates connected to this carbon. 1, 2, 3. There's our three phosphates. So we have adenosine triphosphate, ATP. And when we use ATP, we're actually going to break this chemical bond right here, that chemical bond. Although there's chemical bonds here, 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 and everywhere else on this ATP molecule, not all covalent bonds contain the same amount of energy. It turns out that this covalent bond right here contains the highest amount of energy. And we're going to call it a high energy bond. When we break that high energy bond, we're going to release energy. And that energy is going to be used to run different processes in the cell, such as active transport. So when we break this chemical bond, we're going to end up with two products. One of the products is going to be ADP, and there's our two phosphates, 1, 2. So this is ADP, adenosine diphosphate, plus we're going to end up with an inorganic phosphate. The I stands for inorganic because this phosphate group is no longer connected to a carbon-containing compound. So we're going to refer to it as an inorganic phosphate. Later, through the process of cellular respiration, we're going to recreate a chemical bond between ADP and this inorganic phosphate. And the energy used to create that chemical bond is going to come from the energy stored in glucose. And we'll talk about that later when we talk about cellular respiration. So that is ATP. The next thing I want to talk about is NAD+, a carrier molecule. NAD+ is like an empty truck. So let's go ahead and call it that. It's a carrier molecule, but let's think of it as a large empty truck. And its cargo is going to be 2 high energy electrons and a proton. So let's go ahead and write that down. 2 high energy electrons and a proton. That's the cargo. When the cargo is loaded on the empty truck, this yields NADH. So this is going to be our loaded truck. NADH is going to carry enough energy in these two high energy electrons to ultimately produce 3 ATP. And the proton is going to contribute to the proton motive force in cellular respiration. Let's break this down a little bit further. I'm going to separate these two electrons and write them like this. One electron, there's the other electron, and there is our proton. When I take NAD plus, and I add this electron to it, this electron is going to replace the missing electron in NAD+. That is going to yield NAD. And then this electron plus this proton is going to be equivalent to a hydrogen atom. The proton being in the nucleus, the electron orbiting the nucleus, that creates a hydrogen. When I attach this hydrogen to the NAD, I get NADH, our loaded truck. The next thing I want to talk about is FAD. FAD is another carrier molecule. It's also like a loaded truck, except it's going to carry a little bit less energy, ultimately only producing 2 ATP. So let's go ahead and talk about that one. So FAD, that's our empty truck. And the cargo is going to be 2 high energy electrons and 2 protons. This is the cargo. Now these high energy electrons, again, only carry enough energy to ultimately produce 2 ATP. Not quite as much as NAD+. So that's our cargo. And this is going to yield FADH2. This is going to be our loaded truck. Now again, let's see how this actually works. If I break this up into smaller pieces, an electron plus an electron plus a hydrogen ion plus another hydrogen ion, you can see that if I attach this electron to that hydrogen ion, I get a hydrogen atom. And if I do the same here, I get another hydrogen atom. So if I take FAD and I add 2 hydrogens to it, I get FADH2, my loaded truck. And that's going to be it for energy carriers and energy.